VCAA 2012 Exam 2 Geometry Trigonometry. A rectangular block of land with 50 metres in length, 85 metres. Calculate the area of the block. Okay, so the area of a rectangle . 50 times 85 equals 4,250. In order to build a house, the builders dig a hole in the block of land. The hole has the shape of a right triangular prism. Okay, dimensions are given on the picture. Calculate the volume of the right triangular prism. Write your answer in meters cubed. So it's volume, so you work out the area of the triangle here and multiply by the height of the prism. So area of a triangle, half times the base, which is 25, times the height, which is 4, times the height of the prism, which is 20. Put that in your CAS, and the answer, 1,000 meters cubed. Once the right triangular prism shape has been dug, a fence will be placed along the two sloping edges AF and DE, and along the edges AD and FE. Calculate the total length of fencing that will be required. So in other words, we want the perimeter. In other words, we want the perimeter of this shape here. So we are going to have 20 and 20 plus we want 2 times this length DE. So to work that out, we use Pythagoras theorem. So it'll be 2 times the square root of 4 squared plus 25 squared. Put that in our calculator. 90.6359. Check how many decimal places to 1 decimal place, then write it correctly. 90.6 meters. Question 2. A contour map for the rectangular block is shown. Part A. Determine the difference in height between point P and point Q. So P is on 2 meters, Q is on 14 meters, so we're just going to do 14 take away 2, 12 meters. Sketch the cross section of the block of land along the horizontal axis PQ below. So you can see that the contours are very evenly spaced. So P starts at 2 meters, so we'll put a little dot there. Q finishes at 14 meters, so put a dot there, and because it's pretty much straight, we draw a straight line. The bearing of point Q from point P is 42 degrees. So point Q from P, so we're at P, that's 42 degrees in there. Okay, determine the bearing of point S from point P. So that's 90 degrees and 90 degrees in there. So if that's 42, that will be 42 in there. So the bearing is 90 plus 42, 132 degrees true. Now find the bearing of point S from R. Okay, because it's a rectangle, this will also be 42. 42, this is 42 in there. Okay, you can work that out by doing this and using your Z rule and then using your Z rule. This will become 42. So as a bearing, 180 plus 42 is 222 degrees true. The tree is growing near the block of land. The base of the tree T is at the same level as the corners PS of the block of land. So it's a flat piece of block of land. Show that means you have to show your calculation. It's giving you the answers. You cannot use the answer it gives you in your calculation. Right, we want to show that ST is 41.81. So it's not a right angle triangle, so the first thing 180 minus 47 minus 72 equals 61 degrees. So put that in there. And now it's a matter of the sine rule. So 50 over sine 61 equals length ST over sine 47. Cross multiply. Divide by sine 61 on both sides. And ST equals 41.8098, which is 48.81. You will get the mark for the working, not for the answer, because the answer is given. Part B. From point S, the angle of elevation to the top of the tree is 22 degrees. Calculate the height of the tree. Remember, it says they are on the same level. So S and T are on a flat piece of land. So that's the horizon, the flat piece of land. There's your tree. The angle of elevation to the top of the tree is 22 degrees. Find the height of the tree. And we know this is 41.81 from the previous question. So then it's just a bit of SOHCAHTOA, opposite, adjacent. So tan 22 equals the height of the tree over 41.81. 41.81 times tan 22 equals x. X equals 16.892. 1 decimal place. X equals 16.9 meters. Question 4. Okay, we have 3 triangular sections as shown in the diagram below. Okay, they just give you the information in the diagram. It's always written and in the picture. Calculate the length OA. Okay, so we have a right angle triangle. That's the adjacent. That's the hypotenuse. So it is cos 30 equals the adjacent over the hypotenuse. So 10 times cos 30 equals A. A equals 8.66 to 2 decimal places. Part B. Determine the area of triangle OAB. Now we have 2 sides and the included angle. So you're going to use the method that you know is half AB sine C. So half times 10 times 8.66 times sine 30. And the area equals 21.7 meters squared. The triangles OBC and OCD are similar. The area of triangle OBC is 35 meters squared and the area of triangle OCD is in meters squared. Okay, so it's a similar, and we want to compare areas. They're similar triangles. Okay, so first of all we have 2 lengths, 10 and 14, so that's our scale factor. Might do this one over here. Okay, 10 to 14. We're comparing areas, so you must make the area scale factor 100 over 196. Then you make your 2 fractions and equate them. So 100 over 196 equals 35 is the area of the small one, and 10 was from the small triangle. We put it in the numerator, so I must put the area of the small one in the numerator. Cross multiply. 100x equals 6860. Divide by 100 both sides. X equals 68.6 meters squared. And part D, determine the angle CDO. So I want to know this angle here. Alright, it's not a right angle. I know 14. Because OCD and OBC are similar triangles, this angle and this angle will be the same. So I've got more information here to work out this angle. Right, so the first thing I'm going to do is find out length BC. So I use the cos rule to find length BC. Ten squared plus 14 squared minus 2 times 10 times 14 times cos the angle in between, which is 30, and that equals 7.31525. Now that I have that length there, 7.31525, I can use the sine rule. So 7.31525 over sine 30 equals 10 over sine C. Cross multiply, and we have, I'll skip a few steps, theta equals sine to the minus 1, 10 times sine 30 over 7.31525, and theta equals 43.118, and correct to the nearest degree, so theta equals 43 degrees, and that is the end of the module.